So hello everyone and welcome. I am Jose Huerta. I'll be your host and moderator today for this webinar, Architecting for AI. The idea of today's event is to explore some very interesting topics around AI and enterprise architecture, but in a very conversational approach. So throughout the webinar, please feel free to ask questions or anything you may want to get to the panelists or guests, and I'll be happy to forward some of those to them. Yeah, we'll still have some time for Q&A at the end, so don't worry if you just want to follow the conversation. We're more than happy to do that. I have the opportunity and pleasure today to spend some time with three stellar guests. We're joined by Badar, Sandro, Mancuso, and Daniel Hulme. Sandro and Mash are co-founders at Codurance, where they help organizations become more adaptive and innovative through well-crafted software and craftsmanship values. And let's say that they're building scalable systems and modernizing legacy systems is part of their bread and butter. We have Daniel, who's a leading expert in artificial intelligence and emerging technologies, and he's also the CEO of Satalia, a company that helps solve industry's hardest challenges by using AI and data science. Today, we'll be talking about architecture, AI, etc. But this is something that has become quite mainstream. Right, it's something that if you look at the news is coming up everywhere. You have things like OpenAI with GPT-3. You have the AlphaDog challenge with DARPA trying to get AI to fly against pilots, and overall it's something that is quite a trend now. So before we start, why don't we set a little bit of the context of what we mean by some of this topic now, AI, for instance. So, Daniel, what can you say about that?
So AI is a used and abused term at the moment, and I think that unfortunately it's synonymized with technology. And we all know that technology is very good at alleviating frictions from organizations, but AI is quite unique in the sense that it's a technology that's been around for many decades and actually has multiple branches. And I want to just actually define AI in two ways. The first definition, which is probably the most popular definition, is getting computers to do things that humans can do. And over the past decade, we've managed to get machines to do things that were traditionally only in the domain of human beings. Deep learning neural networks now allow us to get computers to recognize objects and images, to be able to correspond in natural language. And because humans are the most intelligent thing we know in the universe, and because we get machines to do things that humans can do, we then assume that that's intelligence. Now, actually, I would argue that humans are not intelligent, but that's a different talk. There's a different definition of AI, which is not so popular, but I think is more robust. It comes from the definition of intelligence, which is goal-directed adaptive behavior. Goal-directed in the sense you're trying to achieve an objective. Behavior is how quickly can you move your resources to achieve that objective, but the key word in that definition is adaptive. Ultimately, what you want to do is build systems that make decisions, learn about whether those decisions are good or bad, adapt their own understanding of the world so that tomorrow they can make better decisions. So the true paradigm of AI are systems that can adapt themselves safely and ethically in production. And if I was being brutally honest, I haven't seen any really successful complex systems in production that currently adapt themselves. So I think that we're still a long way from actually seeing these technologies proliferate into our organizations. But for me, that's the bar that we're trying to achieve.
Okay, and what are some of the ways in which the modern enterprise is using this stuff, right? Like you mentioned decision making, you mentioned a lot of areas there. What are some of the applications so far?
So I think at the moment, people are synonymizing AI with machine learning. Machine learning is very good at finding patterns from data. But actually, I would argue controversially that companies don't have machine learning problems. They have decision problems. Ultimately, machine learning finds insights. You want to use those insights to make decisions that drive value in your business. And decision making is a completely different field of computer science. They used to be called operations researchers. They are experts at discrete mathematics, optimization. In reality, what you want to do is build systems systems that combine machine learning and optimization, and then have those systems adapt themselves in production. So machine learning at the moment is being brought into our companies because there's a bit of a trend around machine learning. But I think that over the next 5 years, there's going to be an emphasis on using those insights to make decisions. The really sophisticated and smart companies that we work with understand the difference between machine learning and optimization, and are now starting to adopt these technologies in a smart way.
I have a question for Daniel. I'm going to start hacking the structure.
Yeah, go for it. It's a conversation, sir.
So then you mentioned that companies have decision-making problems. So for example, when companies say, "Oh, we need AI or we need machine learning," but so how do you go about requirements, understanding what they really need? Because if they have problems making decisions, so how do you go about understanding their needs and then tailoring a solution for what they might think they need, or
yeah, so it's a great question. So the companies, the way to distinguish is that a decision problem typically has an objective function. I'm trying to route my vehicles efficiently. I'm trying to allocate my employees to maximize utilization. I'm trying to figure out how to spend my marketing money to maximize my reach. It has some sort of objective that you're trying to achieve, some sort of measurable objective. Machine learning tends to be a little bit different to that. It's usually trying to find patterns and insights from data. So can we take data, organize it in a way to try to enable us to find patterns, and then what we want to do then is interpret those patterns and then use those patterns to make good decisions. So we typically try to understand, whether a client is wanting a machine learning type problem or an insight extraction problem or a decision problem, and you tend to find that most clients have decision problems. That's where you start. Now you can work backwards and start to use machine learning to feed insights into decision making tools, but we really typically start with decision making. Does that make sense?
Yeah, to a degree.
Yeah.
This is an area that I don't know much about it, so I'm very curious.
It's actually, I remember at university, actually, my AI teacher telling me about, at the time there was data mining, and you would talk about data mining as actually trying to find the answers to the questions that you don't even know the questions for right now. So it's the insights, I guess. If you don't really know what you'll find, but you are trying to look for certain patterns, would you classify that as the kind of insight aspects of machine learning? Is that where you would
that's
data
right.
mining kind of fit into that, do you think?
That's right. Let me give an example. Lots of companies right now are wanting to make better use of their sales teams. So they're saying, we want to use AI to sell more stuff. Let's use machine learning. Well, what machine learning can do is profile customers. So you can segment customers and identify whether a customer is going to churn or is ripe for upsell or cross-sell. Machine learning can also profile salespeople, understand their skills. This person's good at dealing with churn, upsell, cross-sell. These are machine learning problems. But then what you have to do is match the right salespeople with the right opportunities. That matching problem is a decision problem. That's really where the value is. The profiling is just a part of that process.
And around the decision making, there's other aspects also, right? Like, because it's not only about making the decision, but also the data that you have available, and how does that integrate with, maybe systems that you've been using for a very long time, right? And now they need to evolve in order to plug into this new kind of use case, let's say, right? So what are some of the challenges when it comes to adapting AI or machine learning in this case to those architectures or those systems that are already in place?
Well, Sandro and Mash, I'm sure can talk to this, but one of the biggest challenges that we have is customers want to make decisions, but actually the data isn't available to allow you to make those decisions. So they'll say, we want to be able to predict churn on our website, to be able to understand where people are clicking, blah, 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 and understand if they're going to go and buy from another customer. And actually, if you don't give me the right data to help me find those signals, then I'm not going to be able to solve that problem. So very often, actually, it's there isn't enough data or the right signals in the data to allow you to make the decisions. And what we typically do is go and talk to an expert and say, how are you making that decision? How are you determining whether somebody's going to churn or not? And ask them what data do they use to make that decision? Because if they're using data, for example, the conversations that they have in the coffee machine or the weather, then we need to get access to that data to be able to then build systems that make decisions.
Mhm. I mean, I can definitely add to that. Is that data, as you said, data as a system of record is extremely important. It's kind of understanding that historical parts or aspects of data. And up until now, or often the traditional systems, what they've had is a bit of an incremental approach. They will change data in situations. So it's mutable databases. You know, they'll go and change the value, but the previous value is not known unless it falls kind of across the window of their, you know, ETL operations that actually then take it down towards a data warehouse. And there you've got, you know, maybe kind of star type schemas where you're basing things off timelines. So you start building a system of record, but it's actually much more coarse-grained. And now we are coming towards certain architectures, like, for example, event sourcing, that actually allow you to keep immutable data, right? So snapshots of data and keeping change as your kind of real source of truth, or changes to data as your real source of truth. And that then feeding into other systems where you start then building projections and you start building the kind of views or a projection on the data that you need for solving different types of problems. So I think data is one aspect that is extremely important to understand. And how you create the data, I think also is really important. It's not just about just, you know, keep everything, but it's rather really understanding what are the key domain events within your system, because you're actually trying to come up with the granularity of the data or system of record you need, even sometimes before you're actually thinking about how you'll be able to use that data. So things like, for example, domain-driven design and those event sourcing, event storming and those kind of things can help you really identify what kind of data that you should be keeping that further down the line could actually help. But actually, again, I think, Daniel, you may talk about data lakes and how much of a problem they are. So I'm not advocating data lakes on the other hand.
Yeah, I would say that just to add to what Nash was saying, because we've seen many times where organizations say, look, we need to change our systems because we need to dump some data into the data lake. So, but what kind of data? I don't know, just dump what you have. So just push, like, you have this system, just push some data to where? Oh, to this place in here, to this blob of stuff. But who's going to consume that? How, I mean, we don't know yet, but just dump it in there, and at some point you're going to figure it out. And I think that, Daniel, we were having a conversation another time. You were mentioning data lakes and maybe ponds. Maybe you could shed some light in how we could provide the data in a way that is more useful, let's say. And just before, there is another thing. This is the traditional systems going into pushing the data out, but there's also traditional systems consuming, because in one of the projects that we worked, it was the other way around. Like our systems, the system that we were working on, we were consuming the data that your systems were creating, right?
Yeah, that's right. So I do see a trend at the moment in industry of companies panicking and saying we need to build a data lake and we need to get all of our data into one place, which if you can afford that, then that's great. But my advice is that you start out with what problems do you need to solve? Get a whole backlog of applications that you want to build, and then over time start to build out your data lake. And you'll find that those applications require different SLAs in terms of querying that data. So so if you build a data lake, please don't expect that you'll be able to then build applications on top of it. Very often you have to create data pools. And one example, I guess, that we've worked on collectively with Codurance is we built Tesco's last mile delivery solution. Now, Tesco have to provide slots to customers in less than a second. And that means, and then you have to optimize those routes between the next customer coming in, which might be a few milliseconds. So there's no way that you could be pulling and pushing data in and out of a data lake. You have to have in-memory databases, and you have to have that being operating at exceptional speeds. The challenge then is making sure that the data in the data pools are aligned up with the data lakes. Otherwise, you create data ponds. I think that, again, the other mistake that we're seeing companies make with regards to data lakes is they think by collecting lots of historic data, they're going to be able to predict the future. And actually, I think that this is a really is a big mistake. There are two flavors of machine learning problem. One which is called a first order chaotic problem, where you can take 3 years worth of historic data, you can build a model to predict the future safely, no problem at all. Actually, most problems aren't first order chaotic problems, they are second order chaotic problems. Second order chaotic problems mean that you can't predict the future based on the past. You have to bring in lots of different data in real time, look for real-time indicators and adapt your models in real time as the world's changing. That's a completely different architecture. And again, you wouldn't use a data lake for that. So start out with what problems you're trying to solve and then work backwards in terms of what is the right infrastructure to service those problems. Does that align with what you do? Yeah.
Yeah, which also brings the subject of data locality, right? Like, where do you keep that in order to consume it, or in which format, right? Because when we're talking about these models, right, the idea is that the data may need to be pre-processed, right? Like, you may not get it straight out of the source and be able to use it, right? So so that's definitely a constraint. So there are other areas, right? Like, how do you work on reusing models and reusing some of these patterns, especially if you're going for something like agile software development, where you're evolving a lot of the product that you're building at the same time? So can you discuss a little bit about that?
Sandro, I'm actually, you guys are experts at this, but one thing maybe I can mention that you guys can riff off is that I guess historically people have been concerned about siloed data, and one approach to dealing with the siloed data is building these data lakes. But what we're seeing, interestingly, is companies creating silos of machine learning modules. So a lot of companies are building data lakes and then creating some sort of analytics layer, like they're putting Tableau on top of it or whatever, and then they're saying, look, we've got AI. This is not AI. But if you want to build architecture organizations for AI, you need to have a data lake. You need to have data pools or data ponds that are servicing those applications. You probably need to have a layer where you can build and create reusable machine learning models. And those machine learning models might be pulling data out, processing it, and giving the solution, or they might be pulling the data out, processing it, and putting it back into the data lake, so you can pull it out faster later on. So actually architecting for AI, making the best use of these machine learning models is super complicated, and we haven't even got to the point yet of where we're having to build systems that adapt themselves in production.
Mm-hmm. It's actually, it brings me to mind around kind of, and I'm going to say the word microservices based type architectures, right? Where you kind of have these distinct pieces of processing that actually have their own data, but they publish, and so they have kind of an interface where they are publishing, but they're also receiving data. So they're kind of working in their own right, and in some cases they are actually asynchronous. They are, someone asks and they kind of take part in the response. But in other cases, they could be quite event-based, right? And even event-based systems, asynchronous, sometimes people think, okay, it's asynchronous means that, I don't get real-time behaviors, but you can, depending on the scalability, the latency of that particular service, and how quickly data can come to it, right, as well. So this reminds me of kind of this. That's why the whole microservices based approach came to mind, is because one, you can have distinct processing units related to, for example, machine learning, optimization, and those kind of things that are receiving data in their own way and are publishing and have this kind of interface that others can then take from and make certain decisions and so on. That's one aspect of it. But the other aspect is the evolution of these services, right? If, for example, one is that they like the normal evolution, which is evolution through changing the processing itself, the code or whatever itself, right? So that's not the kind of the AI part, but that in itself means that you can actually bring further evolutions to that without impacting other aspects, and you can evolve your learning on that side. But the other aspect is, and it's just a question for yourself, Daniel and Sandro, is that actually if you enshrine the protocol or the kind of the pre and post conditions at the interface level of these services, would you then be able to kind of establish certain kind of boundaries for an adaptable system as well. You know, it kind of almost like a protocol-based boundaries for a system that would adapt and would not go past a particular point. You know, I don't know.
I could, maybe I can bring this to life, and then maybe Sandro, you can comment on that. But let me try and give you an example. We're all now working more and more remotely, and organizations are going to be interested in how we are connected to each other at work. So they're going to be collecting all of our data about our emails and Slack conversations and calendar. They're going to be bringing all of this into a data lake. And what we're going to want to do is to determine people's skills based on all of that digital footprint. So imagine we've got a machine learning module that could pull in all of those conversational data and all of your feedback and all this kind of stuff, and essentially determine your skill level at software engineering or at data science. Now, that module can be reused across different parts of the organization. It can be used for feedback, it can be used for career development, it can be reused for determining people's pay. Now, if you try and build a module, a machine learning module that's pulling all of that data together, doing natural language processing and trying to provide skills in real time, it's not going to be possible. It's very, very difficult to do that in real time. So in this particular case, what you would have is you would have that module running in batch, probably overnight, trying to determine people's skills, putting that data back into the database so that when you do have applications that need it, like feedback and like pay, that it can come straight out of the database. It's a great point that you made, Mash, which is doing that in a safe way is really hard, because, you know, if you've got wrong data, if you've got bad data, I might determine that your skill level in software engineering is 1 when actually it's 7, and then I might be making decisions about your pay, which has lots of ethical and other legal challenges.
Yeah, and there are, for me, the architectural modularization, if you like, is key here. Because some of those modules, for example, the project that we worked together, Satalia was working on the logistic for the vans to deliver and stuff. We were working on the online store. So there were many features that we had to build that related to the customer journey, to add things to the shopping basket and discounts and pricing and stuff. So there were a lot of other features that were not related to the actual slot that they would choose or that would be available to them. That's where the Satalia intelligent engine would be providing the data. But creating that clear separation of the modules and a clear interface, we could keep evolving the online store and releasing the online store independently, the same way that they were experimenting, they were evolving their models and algorithms and stuff independently from us. So having that clear separation of the modules allowed us to evolve, because those two systems, they not only have different release cadences, but they also have engineers with completely different skills. So this is also very important when we talk. It's not only about the data segregation, but it's analyzing what is the release cadence of all those models, and what kind of people are working, or what kind of skill sets that you need to have to work in those modules. Because if they are significantly different, they probably will use different tools, right? So to build those solutions, they will have, so you will probably want to keep them a little bit separate from each other with a very clear interface in between.
Yeah, one great example of that, just to bring that home, is when with Tesco, when we're doing online deliveries, there are all of these different components that are having to interact. One important component is there is what we call a routing engine that calculates how long does it take to get from A to B. So be able to optimize routes and to be able to figure out what slots to show customers, all this kind of stuff, you have to have an engine, a service that calculates how long does it take to get from A to B. And that is its own service. But even just within that service, to calculate how long it takes to get from A to B, you might need a machine learning module that predicts how long is it going to take to deliver to this customer, what's the current traffic. There are many different parts of that also require machine learning. But you're absolutely right, Sandro, that routing engine is a really good example of a service that had its own team, different skills, different technologies, but it worked in an elegant way.
Mm-hmm. And but the follow-up to that is, would there ever be a situation, let's say, where you want to actually have a more of a cross-functional team? Because one thing we do realize that, of course, data scientists or AI experts have a very specialized skill set. And they are doing some software development as well. Actually, they're taking their ideas and their kind of mathematical models and trying to put them into an executable form, and that's programming, whether it's in MATLAB or elsewhere, right? But and then you've got kind of more general, back end or front end engineers and so on that are actually forming part of the whole application, right? And on one end, as you mentioned, there is a very good reason to kind of, the skill sets are so different that them working together might cause, so there's a different rhythm, different cadence, different skill sets, and would cause issues in terms of cooperation over less defined boundary, which essentially a team is. But is there a situation where you would actually want that team to be a kind of a very cohesive team? Would you want them all to work in a cross-functional way and even have some crossover between those skills?
Sandro, I'd love to hear your opinion about this, and I'll share mine.
So I think that it really depends on the skill. In this example specific, like we are talking about data science scientists and the technology they use, the skill sets that they have compared to the, let's say, our cross people, the kind of engineering skills that they have and stuff, I struggle to see because of the release cadence. So for example, first of all, I would like to make a distinction between a cross-functional team and cross-functional people, right? So normally what you want to do, in general, what you would like to strive for is a cross-functional team. But I believe that this idea of cross-functional people, where everyone needs to be good at, or at least know a bit of everything, I think that is a good goal to have, but in practice, you end up having a lot of average people and you don't benefit from the real experts. And I would rather have a team that there is some people that are understand a bit more about everything, but I would like to also benefit from experts in the team. So I normally like cross-functional teams. I'm less so keen on cross-functional people. However, even for cross-functional teams, for me, there are some limitations as well. And those are related to what I mentioned. When you have people that work in a completely different skill sets, different technologies, and the things that they do, they normally have a different release cadence. For example, Daniel, correct me here, but sometimes this is just my assumption. So there is a lot of experimentation that happens in AI, ML, and stuff like that. While in the more traditional engineering, of course, there is experimentation in terms of innovation, but normally when we get down to the feature, even if it's an experimental feature, from an engineering perspective, is well defined. It might be a business experiment, but feature-wise, normally we have a better definition of what we want, which means that the release cadence that we can have normally is a little bit different. So when that is the case, technology or release cadence skill set, I normally prefer a separation of the teams. I think that is more, it allows those different skills to evolve independently at their own cadence.
I absolutely agree. We've tried in the past to have cross-functional teams, and we're talking here not just about software engineers and designers. We're talking about data scientists, machine learning operations people, optimization people, discrete mathematics. You've got a whole plethora now of additional skills that we're now trying to bring together to build AI solutions. The times where we've made it work, and it's probably only really once at the moment, is where we have exceptional people that can actually get up to speed in terms of what optimization is, what machine learning is, what the expectations are in terms of software development standards, and they have a shared language. Now, you very, very rarely find those people where you've got an imbalance, either in capability or in language. It's very difficult to make those cross-functional teams work. And it's easier to have them separated out and essentially act as services. You're the data science service, you're the optimization service, you're the software developer service. Unless you're lucky enough to have absolutely exceptional people that have the same language, the same respect for each other's disciplines.
And there are things that you need to consider, because if you want to separate those teams, the architecture or the modularization, as you called it before, Sandro, also needs to allow for that, right? Like if you're deploying your model with your application, every change in the model will mean redeploying the application, right? And vice versa. If you deploy through containers, and you have the separated, you can have services with the model. You have different release cadences, etc. But then you also get the let's say complication, no, of managing. Imagine you have one application, but 10 30 different models, right? Like you need to manage all of that complexity and deployment individually, right? So there is also an opportunity there for having things like Redis AI, right, where you have like a model server, something that would allow you to plug models into it, keep a consistent API way of working with those models, right, and have that deployment of that continuous evolution going on in the background without having to break everything up or having to make too many changes, right? So
Yeah.
it's not only about separating the teams, it's also how you design your system needs to allow for that to happen. And a lot of the times, this is what part of preparing for AI is, right? It's about breaking those dependencies and understanding where those things are, before you even go into, okay, let's start gathering data, or let's start, because if you're not ready, you're not going to be able to get the most out of it, right?
This
Absolutely.
actually, I just thought of this. Actually, has another impact, and of course, totally agree with that. But another aspect is that it has an impact on how you release your product, right? Because if the cadence is different, what does it mean for you? Like, for example, a software, one thing, kind of a more traditional software development or backend team or cross-functional team, working with a separate AI machine learning team, right? If they are releasing these features that rely on that service, what does it mean to release the increment here, right? And then if you're releasing that increment, you can, but then you have to start thinking about actually what's the stop gaps, or what are the series of stop gaps before you get the real AI actually doing the work, right? Is it some 20 course old at the back kind of working out manually, while that happens, or do you not provide that service? So you have to start making those decisions at the product level on how this feature would evolve as the kind of the AI or machine learning aspect of evolve. It doesn't necessarily have the same cadence as kind of the main feature releases, right?
Yeah, so it's as you guys know, it's incredibly complex. You have to have a lot of discipline. You have to have a lot of very kind of talented people to make sure you can make that work. What I'm seeing in industry is a hack, which is expecting the data scientist to do everything. Let's just get them to be the data engineer, the data scientist, the decision scientist, and then ultimately software engineer it, put it into production, maintain it, support it. And of course, it's impossible to find those people. But that is now the expectation of data scientists, and no wonder why we're seeing a huge amount of failure in industry of people attempting to do machine learning and it just not getting into production.
Yeah.
There's a cultural aspect to this also, right? Because if you want to, let's say, bring artificial intelligence into that, and let's say you don't have those kinds of profiles available or as available as you would need them, right? There's a part around, just like with quality, or no, there's this thing about building that sort of data science literacy, within the teams and within the, so that it more or less balances out a little bit, right? Like it's not like you can hire as many data scientists as you want, right? Like those, but there is a cultural shift also that needs to happen there, especially if you don't have that availability, right?
I think the concept of also culture is really important, because there is there's obviously a growing concern that we have a certain type of person that's building these types of solutions and not having the right diversity. So when we talk about cross-functional teams here, we're not just talking about data scientists, optimization experts, software engineers. We're talking about philosophers and ethicists and psychologists, and they have their own cadence as well. So how do we make sure that we bring in their perspectives, their expertise in ensuring that we're building safe and ethical AI solutions? It's a really interesting problem.
Yeah.
So,
imagine getting a philosopher into a development team.
I was just thinking here. Of course, there are a lot of new modern projects that the AI is part of their core from its inception, right? But there's a lot of companies that are bringing AI to their existing platform. At that point, for example, I was thinking about like one of the clients that we have, a few actually, and they have a pricing area, they have like recommendations, they have many different things. But if they want to bring AI, they cannot just put AI in there, right? So then I would like to hear from you, Daniel. Of course, like we went through a few exercises ourselves as well. What are the biggest challenges when companies say, look, I already have my systems, but I want to take one part of it and make it more intelligent, let's say. So what are the main challenges that we have? And we can share from our side as well what the challenges are in doing that.
Well, as you know, many organizations can't stop their operations to replace their current systems with new ones. I often describe it as doing a heart transplant on somebody that can't stop working. And obviously that's infinitely more complex than having somebody laying on the bed that you can stop. So it really helps if you're architecting your systems as services, because it means that you can replace those services, test them with new and hopefully more intelligent systems. But if you can architect yourselves as services, then it makes life a lot easier. Actually, what's behind that service, whether it's a rule-based system or an AI-based system, whether it's adapting itself, it sort of doesn't matter. But if you've got a robust service architecture, then you're in good shape. The challenge is how you actually move towards a robust services architecture, and at the same time making sure that you're architecting for AI. So you're architecting these different layers of machine learning and data pools and data lakes and decision layers as well. And again, unfortunately, what we're seeing in industry is not a holistic view across that entire stack. We're seeing data lakes plus analytics, and that's not AI. So, but for me, architecting yourselves as services is really critical. I don't know what your thoughts are.
Yeah. So, for example, what we see sometimes is they say, okay, we want you to have, like, let's say the pricing side of our system or the recommendation side that today is quite, well, not very intelligent, let's say, modernized, but it's part of a big monolith, right? So from my view, like, you cannot just bring in like, okay, I'm going to build a new pricing system, but without knowing how the old pricing system is going to be decoupled, and then this transition as well, right? So normally, like, what we recommend is say, like, look, before we go there, let's have like an architectural workshop and try to understand, if we plug in an intelligent pricing system or logistics systems or whatever, what is the interface? What does that system, the new system, will need in terms of data, and what would provide back to the system? Because then we know exactly where to slice the system, because we need to take the monolith or that group of systems and evolve them, first of all, to create that we call the seam, right? So to create that seam first, where the pricing system or logistics system is, and then push it out. But at that point, we are already creating the interfaces needed by the new system within the existing system, and then gradually decoupling and then rerouting, because then you can test, and you could still use the old system as a backup while you are in the transitioning, or have an experiment, or just release that for a few segments of your clients just to make sure that everything is okay, and then do the switch. But there is a modernization aspect, or architecting or preparing your systems should be modernized, because quite often you will not do the traditional approach that is going to refactor what you have towards an AI system. You'll probably be looking at a new solution, because refactoring towards that will be very complicated, let's say.
I think, and ultimately it goes back down to, if you already had this services-based approach, right, with this modular approach, then it would be easy. But a lot of the times you kind of retrofitting kind of intelligence into existing systems, and they're often built not with that in mind, or they're not even built with a kind of a more modular approach in mind. They're kind of a very complex jumble of various features, and identifying certain areas is very difficult within them, and they're kind of reaching into each other from all sorts of places, and kind of disentangling that, I guess, is moving back to that point where we're saying that actually modularization, to the point where you actually have distinct services with distinct interfaces. They're owning their own data, publishing, receiving through a well-published interface. That's the place to be, right? And if you're gonna start, then start from that. But if you're not there, then you have to go on a journey, basically.
Indeed, and actually interesting. One of the reasons why I think we're not seeing true AI in enterprise right now. When I say true AI, I'm talking about adaptable services, adaptable systems. Is that if you say to an IT director, I'm going to put a system in place that behaves differently today than it will tomorrow, they say, no way is that going into production. I need to make sure I understand how my systems are going to behave, because I have all of these other dependencies. And if you say to an IT director, I'm going to put a system in production that needs to make mistakes for it to get better, they say, no way, I'm going to admit to my CEO that I'm putting a system in that's making mistakes, even though automation is making mistakes all of the time. It's just not learning from it. But my advice is start with automation, start with a service that you know that you can in the background ultimately adapt.
And this also brings, ethical questions, right, and security questions, right? Because how, we want it to make mistakes, but we also want to control the impact of those mistakes, right? Or we want to have fail safes, and that becomes kind of difficult now. If you look at their models now, before I was talking about GPT-3, so the sheer size of the thing makes it really difficult to know exactly what is happening inside, right? So getting that let's call it observability around what is actually changing, right? Or how is it actually evolving? What are the things that are happening in there is kind of difficult on the AI side. And it's also difficult when you're looking at at the whole system. If you want to look at the architecture, you also have to design for that, right? This is where things like Mash was mentioning before come into place. Like having that data out of the box that will allow you to replay things if you need to understand what is happening as it's happening, and not only when it fails, right? Because that may already be kind of late, and that's an interesting problem. Sure. There.
So this actually touches upon a concept called explainable algorithms or explainable AI. And for the most part, machine learning is actually quite difficult to explain. It's quite difficult to look inside these models and understand how is it making its decisions, and then seeing if it's might be making decisions that are incorrect. Actually, optimization, decision science is much more explainable. I won't go down that route, but one of the things actually I'd like to work with Sandro and Mash on is there are well-established governance structures for good, safe technologies, for safe software engineering. There's a whole load of stuff flying around the internet, gimmicks around AI governance, and I'd love to work with you guys on what an AI governance framework should look like, taking what your knowledge from how to create the right governance structures for technology for IT, and applying that to systems that can be adapting themselves, where we have to also address ethical questions. I'd love to work with you guys on that.
This actually reminds me of the concept of evolutionary architecture, right? And evolutionary architecture, they are more evolutionary in terms of release-based evolution and not adaptability in production. But within there is a concept of fitness functions. And fitness functions are effective tests, or at the very rudimentary level, they are tests that are running in production. And they are even intervening when they fail from that operation to then happen. So, and that it reminds me of that aspect, is that where you're kind of building, not only you're building the service that adapts, but you're building the fitness functions around it that almost intervene, almost like a, you know, a protective parent, basically, to kind of stop it in going into certain directions, right?
Yeah, they tried to make that work for they tried to make that work for the stock markets, and we see what happened there. But just shows you how complicated it is. But yes, absolutely, we need those stopgaps. Absolutely. Yeah.
Yeah, and you know, like because for example, we've, you know, testing or test automation is not an easy thing, right? And we often spend more time in test automation than in building production code, right? And it just goes to say, like, and this is verification where the behavior is static, right? And then actually building that into practice of guarding against dynamic behavior, or kind of parameterized kind of or property-based type. This is another kind of complexity altogether. But you know, so speaking of property-based testing, this is another thing that we have, right? Which is you kind of create certain functions that actually describe what it should have, right? At a higher level, at almost like a mathematical property level, basically. So this is a function, it has an X and Y, and you know, given that, it should be, this formula should hold true, right? And I know that simplifies to an extent, but actually that property-based testing is an area of software engineering and testing that could be very much applicable to adaptive systems, because they don't test examples, they actually test the property of what needs to happen.
Nice. Yeah, cool. Very cool.
Yeah.
So it's a fascinating subject, but we are almost on time. So before we go into Q&A and answer some of the really good questions on the chat, what would you guys recommend to someone who is either trying to get into this AI kind of thing in the enterprise, or is either thinking about evolving the systems, or starting to use some of that into their current systems? Is there any recommendations for them?
Nice. Sandro, do you want to go first?
No, so from our side, like I believe that we are more on the engineering side, so is evolutionary architectures, so different architectural patterns, but also a lot of software modernization patterns as well. Because again, you are not just building from scratch, well, at least most people are not, but understand how do you take your system from where it is to a place where you can plug in all those sources of innovations that you want. So, but in order to get from where you are to there are many different approaches that you can use architecture at the architectural level and at the code level to be ready to isolate the bits that you really want to have fast innovation. So those are the.
I think another one is an architecture. You know, Conway's law, right? Architecture and organizations go hand in hand. And the book on team topologies, that is also, because some of the concepts we're mentioning, where you have a separate kind of expert team, they call that a complex subsystem team, and how they interact with the other teams and so on is very well covered in that book. So I would recommend that as well. I think is very relevant from an architectural point of view.
But yeah, my advice to anybody starting out on their journey of AI is, or at least any organization that wants to start embracing AI, is that there's a huge amount of hype out there. And there's a huge amount of misunderstanding. And actually, AI has probably had the biggest hype out of any technology, certainly in my lifetime. And I think that we need to acknowledge that it probably will have the biggest impact on humanity above any technology. But there is a huge amount of hype. And my advice is try and find an expert or a group of experts to help you go on that journey, and make sure that you are looking at the pedigree of those experts. I don't want to kind of insult anybody on the call here, but anybody that's now dabbled in analytics, or done maybe a technical degree or whatever, is now repurposing themselves as being an AI expert or a data science. And actually, if for some reason, let's say, chemistry knowledge was really important now to industry, that everybody was getting excited about the formulas and the knowledge around chemists. I would be quite embarrassed if I did an 8-week course or dabbled in a little bit of chemistry and called myself a chemistry expert. So we're seeing a lot of people out there, a lot of technology consultants calling themselves AI experts that really don't understand how to architect these systems. I think there are only a handful of companies out there that do, that have these deep expertise, and my advice will be try and find them.
Good advice.
Okay, so let's move on then to the Q&A, right? Like we have a couple of questions. Let me roll here. So when we were talking about data, yeah. 1 second. So this is from Kanhaya. Sorry if I'm butchering your name. So the data used for machine learning will ultimately be used for artificial intelligence. Am I right in this?
There are four elements to essentially architecting for AI. The first element is data. So you need to make sure that your data is engineered, it's stored, all that kind of stuff in the right way. The second is insights. So using machine learning, data science to extract insights from data. The next layer is decision making. That's optimization, discrete mathematics. And then the final one is then building systems that adapt themselves. AI is not machine learning. AI is this architecture here that I've just described, these four elements interacting together.
Okay. Another question. So you talk about developing decision-making AI by looking at how specialists would make the decisions. Do you develop a system that adapts itself by looking at how humans are adapting the system and replacing that?
Maybe Sandro, Mash, you've got some examples of this, but one interesting example that we have is we've built a workforce solution for a very large tech consultancy company. And essentially what happens is they've got people that they need to allocate to projects. And Sandro, Mash, this is our day job, trying to figure out how do we allocate the right people to the right projects. Yes. So this is an optimization problem. It's a decision problem. We've got all of these projects, we need to allocate these people. Then what you want to do is use machine learning to then profile those people so that you can then better allocate them in the future. But usually there's a planner, there's a human being saying, actually, that decision is the wrong decision because that person doesn't really have the skills and that person's married to this person, so we don't want them working together. And what we can do is we can actually bring humans into the loop to teach the AIs, to actually teach them things that you didn't catch when you were gathering those requirements initially. So actually augmenting human intelligence with AI is probably what we're going to see over the next 5-10 years until we're confident that the AIs can actually make decisions without the aid of a human.
Mm-hmm. It's practically testing, isn't it? User testing in a way.
Yeah. And again, there are loads of principles in your domain, guys, that can be applied to how we do this safely in the AI environment.
Mm-hmm.
Okay. Moving on to the next question. It says, if I may ask about application of AI and risk management, and in particular, interpreting vulnerability scanner output reports.
I mean, it's not my domain, but maybe you guys have a comment. I could probably try and make something up that sounded sensible.
I'm actually trying to understand the question. AI and risk management, and particular interpreting vulnerabilities scanner.
So maybe Bash, while you're thinking about that, I just want to talk to it a little bit more general about risk management. Machine learning can help you determine risks, whether it's a country risk or whether it's a risk of a vulnerability or a risk of somebody leaving. We can use machine learning to determine risks. But the problem is, what do we do when we understand that risk? What are we trying to maximize? We're trying to ultimately minimize a risk subject to a reward value, and that is a decision problem. So again, lots of people are excited about using AI to detect vulnerabilities, but the question is, what do you do once you've detected the vulnerability? What decisions do you need to make, which is decision making? So I don't know, Ash, if you've got.
I was actually thinking about the kind of life cycle of risk when it came to risk management, because there is identification, risk identification, and then there is risk mitigation, and you know, AI to identify risks in a kind of a large space or domain. I could think of, but then mitigation is again a decision problem. But so I wasn't sure exactly what was meant by AI and risk management, especially vulnerability scanner outputs. I'm thinking they're talking about risk identification, identifying certain types of risks. I'm not sure. I'm not sure about the question, to be honest. To give it
I think that there is a domain. There is a domain thing, because risk management is in capital, and I wonder if they are talking about investment banking. Because, for example, I'm working for a healthcare company, so risk management in there is quite different, because there are different types of risks as well. So, for example, there are risks related to patient safety, right? So we want to make sure that our system addresses any risks. Anything we do, we need to think about patient safety. But there are risks related to compliance. There is risks related to certifications and how data is exchanged across different healthcare providers. So there are a lot of different types of risks. One are risks for the business. So if you do something wrong, we might be not compliant to a regulation or certification. Other risks are risks that we can cause to our customers. See what I'm saying? So, and they are addressed in a slightly different way as well. And there is also, again, I just, basically the answer to the question, I don't know, because I think that it's very complex, and there's many different types of risks and mitigation.
Let's get another one. So organizations and companies are at a variety of AI maturity. At the basic level, a proof of principle project does more to help them level up. How do you match your services to the level of the AI maturity of your clients?
Or maybe again, Sandro or Mash, you can talk about how you approach it. If in reality, organizations have a lot of frictions, and AI technology can alleviate those frictions. One thing that you want to do is identify a backlog of opportunities of what frictions to alleviate, and then where AI can be to intervene to help it to alleviate them. I don't really care about the maturity of our clients. Some of our clients are still solving problems on pen and paper. Some are quite sophisticated. I actually care about working with nice people solving hard problems. That's really all my team care about. That's what stimulates them. So actually, if we have an ability to take you on the journey from start to finish with AI, then that's great. If we're just coming in to solve a problem, that's also great. I just want to work with nice people solving hard problems.
I was going to say the same thing around AI maturity. I think the question, a good question would be, like, you need to look at what the organization needs, right? So what would be the highest value to them? There are a plethora of kind of AI solutions available, but what is the actual problem? What should we be tackling first? And I think that should be other than nice people, of course, that should be the driver for what kind of solution a particular client needs to have.
The only watch out that I would say is that we see a lot of companies saying, let's do some machine learning, and somebody will come in, they'll get some data, they'll make a prediction, they'll say, isn't that nice? It'll get put in a drawer and never go anywhere. Actually, getting machine learning into production, maintained, supported is 90% of the job, as opposed to actually building the machine learning model. But again, I would also caution people to think they have machine learning problems. They probably don't. They have decision problems. So again, working with the right company to help you understand what problems you have and what the right technologies are to apply to it is critical. So don't just think we need to be in AI, we need to do machine learning, because we see that failing all the time.
Yeah, hello, so in terms of our services and how it aligns, one of our key services is what we call software modernization. So, and within the software modernization, what we try to do is to take the existing systems and modernize the key aspects of it to match their strategy moving forward, like their business strategy. So let's say if they want to, part of their strategy is to bring intelligence to certain areas of their business. One of the services that we do is to help the companies to prepare their systems to integrate that intelligence. And then we can work with, for example, one work that Codurance does is looking at the existing architecture and modernize that architecture so that it makes it easier to innovate. And as we work with Satalia, we can also understand what kind of intelligence will come in. how that intelligence, where that intelligence will fit, what would be the boundaries, what would be the interfaces, what data needs to go into the AI systems, and what would be consumed by the external systems. And so help to create that plan, and then together.
And also how that is operated, as Daniel said, deploying, operating these things in production is an even more complicated part, right? And I think that's where the AI kind of data science, good deep know-how, combined with good software engineering expertise, together can deliver a very compelling solution, like we've done at Tesco as well.
I would also add something that we've mentioned in previous conversations, right? Which is, it really also depends on the problem that you're trying to solve, right? Because for some of the things, like, there may not be an easy answer to that. There may not be, something that you can just mix and match and apply to it. So you may have to go and do some research first, right? And that is part of the that is part of the thing, right? It's not just the maturity, but can it be actually solved, right? And if it can be solved, like, what do we do? No, that's the idea. Okay, so we are already on time. There were a few other questions. We'll make a note of them and prepare maybe another webinar on a similar topic, or we'll see, right? Thank you very much, guys, for your time. Thank you to everyone who attended, and I hope to see you all soon in our next webinar, whether it's here or some other.
Thank you very much.
Okay,
Thank you very
take
much,
care.
everyone.
Thanks, Daniel.
Bye, everyone.
Bye-bye.